I'm Ehsan Jorat. I'm senior lecturer in Geotechnical Engineering at Abertay University in Dundee, and I'm also Carbon and Biogeochemical Cycle team co-leader at SAGES, the Scottish Alliance for Geoscience, Environment and Society. For thousands of years, components that comprise our planet have been in harmonious interaction, and climate change has significantly interrupted this harmony. Now we are facing with environmental challenges which can only be linked to climate change. Drought has resulted in out-migration of thousands of villages in drier regions across the globe, and often we hear about flooding events in regions with no recorded history of flooding. These are all undeniably linked to climate change. I've been researching on adding function of inorganic carbon sequestration to urban soil since 2014, and since last year, also agricultural soils. My work could prove that soil, if engineered appropriately, has a great potential for removing atmospheric CO2. Our measurements have shown that urban lands, if engineered appropriately, have potential to capture nearly 60 tons of CO2 per each hectare every year, which is a really large number. Considering future urban developments across Scotland, there is a huge potential for including this technique and contributing to the climate emergency targets. By extending this technique globally, perhaps urban and agricultural lands could be used as a sink for inorganic carbon, and through this contributing significantly to global atmospheric CO2 reduction. Although there are still a lot to be done to fight climate change, we need to acknowledge that Scotland has done a great job so far. Government and private sectors have contributed to fight climate change through research funding, introduction of new technologies and innovations. There are many countries across the globe that have set targets to fight climate change, but missing a coherent strategy on how to arrive at their defined targets. Scotland's effort in fight climate change could be used as a model for many other countries across the globe to follow. Well, engineering soil for inorganic carbon sequestration, which is the field and area which I have focused on, and its capacity to store carbon in soil is scientifically proven. So we know that it happens. However, I believe we still need to further analyze the process, especially in micro scale. There are still gaps in science to precisely trace and monitor the sequestered inorganic carbon that forms in soil in short and long term. Soil in general is a biologically active medium, and research should look into finding impact of newly formed inorganic carbon in engineered soil and that impact on microorganisms within soil. What I would like to see from COP26 is acknowledging that climate change is everyone's responsibility, and to encourage everyone in the world to do their bits. Every time we decide to use bicycle instead of car, every time we avoid using plastic bags, every time we recycle, or even every time we switch off an unnecessary lamp, they all help fighting climate change. And perhaps we can also consider engineering a section of our house garden or even a flower pot to sequester carbon inorganically.